Hello and welcome back to another Oxford MAT Livestream. My name is James, I'm the admissions coordinator for Maths at Oxford. This is a series of live streams where we look at topics from the MAT syllabus, do some revision on those topics very quickly, and then look at some MAT questions. Hello to people in chat. Let's get chat on screen as well for a moment. Hello to Anonymous, Anonymous, Fruit Tart, and Zaki Hussein. What a collection of usernames. A real reminder that Slido has different policies to YouTube chat when it comes to, the built-in YouTube chat. Different policies on usernames. Good to see you all. There's a question in there about radians. So let's get that out of the way. Math questions are written in degrees because we're not sure whether or not you know about radians, but we're sure you know about degrees. You're welcome to use radians as much as you like while you're answering them. All of the people marking or people writing the questions or whatever, we all know about radians, so you'll be fine. What was the actual question about radians? Answers in radians still fully credited, right? Yeah. We know what radians are. We're just not going to assume that you know what radians are. Right, I think I'm live. I think I've unmuted. I think the people would tell me. Hello to Dominic, Anonymous, like 3 anonymous people all in a row. And Aaron. Did I miss people while I was thinking about this? Jacob has noticed that I answer with a little force of habit, right? I put this little thing on my answers because we started doing it. We started doing it when there were multiple people manning accounts. We'd seen on social media people put a little symbol, little carrot symbol at the end of the messages. But force of habit, I now do that on almost all chat messages that I send for that live stream stuff. How's that going? Right, everything is 10 choose 5. That's right. Everything is 10 choose 5. 10 choose 5. 10 times 9 times 8 times 7 times 6 divided by 5 times 4 times 3 times 2 times 1. I love that Slido has assigned you the initials EC for everything and choose. Hi Evie as well. There you go. Right, Anonymous asks about Pythagorean triples. I think, what do I think? Well, you know about triangles, a squared plus b squared equals c squared, and maybe it's not too much to hope that you might know an example like 3 squared plus 4 squared equals 5 squared, but I don't think I'm expecting people to know, for example, what's a weird one? What's the weirdest Pythagorean triple I know? What a fun question. 5 squared plus 12 squared equals 13 squared is probably the weirdest one I can do on the spot. So no, but then yeah, standard angle trigonometry. I think so. I have an entire live stream next week about trigonometry, so we'll do some trigonometry next week as well. I would like you to know sine of 225 degrees, for example, among other things. 252 is just the best number. Right, okay, what am I doing? Oh, I've clicked random buttons in YouTube. Sorry if that's caused anything to happen or not happen. Let's find out how people's day is going. So we've got a poll vote. We do this every week to find out how people's days are going. Oh, have I turned off? Accidentally anonymized it. There we go. Not a secret. People are having a good day. That's pretty good. Let's let them vote for that for a moment. We'd like to know if you're having a terrible day as well, because there's some chance that doing some maths on a terrible day, well, if it's really terrible, maybe it can't get worse. Hello to AOL and Avi in chat as well, possibly Avi. So Kay has got a question about writing vectors, because this question sheet includes some materials about vectors, and there's other ways you might, other ways you might write vectors. So we have them in column vectors in these revision notes, kind of on screen behind chat. Sorry about that, but we'll see in a second. I've written my vectors one way. There are other ways to write them. You're welcome to do anything that's reasonably standard. Yes, right, okay. And also in chat, do you recommend we always always saying mathematics opposed to maths in the personal statement and trying to save on characters? Personal opinion, you can use either. The people reading it know what both of those mean. You'll notice that our web address for Maths at Oxford, as featured here, is maths.ox.ac.uk for the same reason that you've mentioned, that it saves characters. Also, I just said maths out loud, so I'm clearly okay with the word. I suppose if you're really saying characters, you could say math, like the Americans do. And everything is 10 to 5 is explaining to Callie that this is a thing from Unique Summer School last week. Right, no spoilers for anyone who's coming on Unique next week. This is the thing. I have 3 weeks of Unique, and I have the same jokes that I do at all of them. So try not to spoil any of these. Congrats to Anonymous in chat who has passed their driving test. So well done them. That's good stuff. I wonder where you did your driving test. Maybe you did it in a Pearson VUE test centre. That's where some people do that. Or maybe you mean you've passed your practical driving test. Double congratulations if you've passed the practical. Right, okay. I think we should do some maths, because that's what we've all gathered here for, isn't it? People are having a 4-star day. There is, I think, exactly one person, the 3%. I think maybe one person who's having a terrible day, and I just want them to know that I've noticed. I'm still going to do the same plan of maths and stuff, but I want you to know that I'm doing that because you voted 1 star. In some sense. Hello Cordelia, I think I missed you in chat there as well. Right, okay, I'm going to switch off chat. I mean, it's still on my monitor, ticking away so that I can see what's going on. A shout out to Callie in chat, who is moderating chat for us and also replying to some of the questions or comments in chat. Thank you, Callie, if you're watching. Here you go. Right. Right, let's scroll up and have a look at the revision notes. So if you want a copy of this, by the way, these notes that I'm scrolling at the top, these are on the MAT Live website, which is on screen and in the YouTube description, and one hopes if you type MAT Livestream into a search engine, then it gives you some sort of AI overview, and the AI has consumed all of the internet and synthesized it down and tells you that you can scroll down slightly further to get to a website with the MAT Livestream on it. So hopefully one way or the other you'll get to the MAT Live page, which has got the worksheets. I know possibly the AI will try and tell you what's on the worksheets as well, but why not just go and get the worksheet yourself over there? You can even get them ahead of the live streams. So if you want to see this trigonometry that's coming up next week, you're welcome to go and get that one. You can also get the solutions. I've got some solutions printed out for myself, which are just on that website too. So if I skip over your favourite question, then at least you can get a written response from me about how I would solve it. Written down. Occasionally the written down thing is different from the thing I do on the stream. That's sometimes because I forgot what I wrote down, and it's sometimes because I want to show you a different method. So there's not no value in being here live. Right, okay. I think I've accidentally undersold this thing we're about to do, which is we're going to look at some revision notes. Let's look at what we need to know about geometry. Here's the MAT syllabus. It says coordinate geometry and vectors in the plane. The plane here means 2 dimensions. So vectors with 2 components and coordinates with 2 numbers. The equations of straight lines, and again we're still in 2 dimensions, and circles, famously 2-dimensional. Basic properties of circles, I've listed a few underneath just to check how basic is a basic property. And lengths of arcs of circles. In the revision notes I've thrown in areas of sectors of circles because I think it's very closely related. That sort of pie chart fact is coming up at the end of these revision notes. Yeah, someone in chat has been to an open day and seen a question about triangles and parabolas, which is one of mine. So that's nice. Nice to see my questions. Nice to see my questions get out there into the wild and then come back again. Right. Okay. Let's go. Let's see what we've got. So I've got a description at the top. If you've never met vectors, which might be somebody, if you've never met vectors, I've got some descriptions at the top. But I wanted to go down to so not magnitude of vectors or distances, because I think it's just Pythagoras. It's a squared plus b squared equals c squared thing. So equations of straight lines. I sometimes get told that the way that I write straight lines is weird. Sorry, I suppose. If we're doing some algebra on the board, then there's a good chance that if I want the line, that's not the colour I thought it was going to be. If I want the line with gradient m through x1, y1, then now I've put a couple of forms of that line up there. You might write y equals mx plus c. You might write ax plus by plus c equals 0, and then try and find a, b, and c. Or you might write this thing y minus y1 is m times x minus x1, which occasionally I've seen as y minus y1 divided by x minus x1 equals m, which is also a handy definition of what the gradient of a straight line is, I think, if you pick a particular point for y. Occasionally I've written a sort of hybrid thing, which has unnerved people before, so I just want to get it out there. I guess this is an alternative. It's very, very similar to the thing y minus y1, but I've moved the y1 on the right. I think there's a chance that I'll do this later, so I just want to show you now to get it out of the way. And there's a chance I'll do this. I think it unnerves people because it's not quite y equals mx plus c. I've got 2 bits of constant on the end here. And it's not quite y minus y1 because I've moved the y1 over. But quite often I want to write y equals on the left and then just go for it. And I don't mind if my right hand side is not quite in the format mx plus c. This is nice because you can say it's the gradient times x minus x1, but wait, when I put in x1, I'm supposed to get y1. I should add y1 now. And like, the reason you're allowed to do those steps is that you're writing something that is unsimplified, but of the form mx plus c. So the online open day, there's a question in chat, online open day, if it was back in May, we did a quick online open day. It was mostly me talking about admissions and then some tutors and students talking about their experiences. We recorded it, it's on this YouTube channel, Oxford Mathematics Plus. So if you go to our channel and scroll back far enough, then you can get the recordings of an admissions talk and a Q&A session. There you go. Yes. At A level, Anonymous has been very helpful here. Anonymous in chat said, at A level, 2 thumbs up since Slido as well. At A level, my teacher taught me to use y minus y1 equals m times x minus x1 because you get the marks immediately for subbing in instead of y equals mx plus c. Yeah, I like that. I can't really think of a math question where you would get marks along the way for doing this because we haven't done very much yet, but I like anything with fewer steps. That's just slightly smoother experience to do, which is why I've started writing it out like this as well. Because y equals mx plus c, there's nothing wrong with it, but you have 2 unknowns there, and once you've solved it a few times, you're fine. Hello to Lushan SPC in chat, who's just joined and said hello. Dominic says you can't use this at A level. I suppose am I quoting a result? Nah. Possibly you should not listen to me if you're about to take an A-level exam where the A-level exam board is strict on what's an acceptable formula to quote. For the MAT, we don't really have a formula sheet or a list of formulas that you're allowed or expected to quote out of nowhere. There's a kind of understanding that people might quote formulas from all sorts of exam boards and specifications and things, so we have to be a bit more flexible, which means that for MAT we end up permitting people to quote a wider variety of things. Scotland, also anonymous user from Scotland says use y minus b equals mx minus a. To use a and b for these points. That's a nice idea, so that you don't have subscripts. And then a and b in here as well. And the anonymous Scottish user wants to put a b on the left as well, so that it matches up with what Dominic's saying and what it says in the notes. I think mostly the thing I've written on the board is an apology. I am going to at some point write this probably, because really I should write out the thing in the middle there and then add y1 to both sides, but I don't want to write it twice. You've seen my handwriting. Writing things twice is not good. It's not great at A level since it skips a simplification step. There you go, that's a good way of saying it, Jonah, thank you. It skips a simplification step, which for me, brilliant. I love skipping steps. But apparently for A level, if you can get a mark for adding y1 to both sides, then you should jump through that hope, write out both, right next to it, I have added y1 to both sides, please give me the mark. I don't know, like, if you're getting marks for this stuff, then write as much as you need to get the marks. Right, Matt is not quite interested in the same things as A-level questions, if that's not immediately clear. It's a good chat though. I like this. Oh yeah. So someone's got a question as well to say, if Matt is on Pearson VUE, how are the written questions marked? And the answer is that we've changed the format a little bit since we moved to Pearson VUE. We have 25 multiple choice questions, and then we have 2 longer questions for which you will type answers. And we've written the questions knowing that you're typing answers, but it's no longer the case that in yours it says, it's no longer the case that in question 2 onwards, it's your phrase, not mine, it's question 26 onwards. It's no longer the case that we have a big question 1. Right, yeah, Rosa says this is called show you're working, which, okay. You can overdo it, can't you? Maybe not. Maybe at A-level you can't overdo the show you're working. Cool, okay. I want to highlight this fact underneath this next bullet point, which says 2 lines are parallel if and only if they have the same gradient, and 2 lines are perpendicular if and only if their gradients multiply to give -1. This is a surprisingly good fact that you were allowed to use. There are some hard revision questions coming up in about 5 minutes, and one of them is made easier by remembering that fact. Okay, that's a clue. We've got the equation of a circle, which I'm sure we've been using in other live stream episodes already. We've got the angle in a semicircle, so now we're onto sort of basic circle facts. Occasionally people, I sort of think GCSE students learn quite a few of these. We've definitely used this one in MAT questions before. The angle in a semicircle is a right angle, and we've definitely used the one about a tangent being at right angles to a radius. There are more, and obviously knowing more facts just makes you more powerful at maths questions, but those are the ones that I've put down as circle angle fact things. If you know more, then I'm not going to comment on other ones that you know. Those are the ones I've listed. It can't hurt to know more, obviously. Somebody is typing a chat message now. I can just know, typing a chat message like, am I required to know? And then there are at least 1 million circle theorems that they might mention next. I'm sure. Don't make me list 1 million circle theorems. Right, okay. I've put this fact down at the end. Notice, fans of radians, just a quick shout out for you. You're going to read questions today, maybe in the MAT, that are written with degrees, and occasionally statements with degrees just look more ugly. So, like for example, here we've got theta divided by 360 degrees as a proportion of a circle, whereas radian enjoyers would just write theta divided by 2 pi, and then they might cancel the 2 pi's or something like, oh my goodness. They would simplify all these expressions quite a bit because some factors of pi, at least, would cancel out. Hi Ginger Biscuit, welcome to the stream. We've just been looking at the revision notes so far. So if you want to look at the revision notes, I'm not going to scroll up, but you could get the worksheet at the MAT Live website. Right. What am I looking at? So we're going to quickly look at chat because chat's suddenly gone off. Mostly degree slander. Yes, the questions are Evie's right. The questions are in degrees, but you can convert to radians if you like. That is allowed. And in written questions, examiners are not marking, for the maths test anyway, examiners are not marking grammar or misspellings. Typos is interesting because I think a cunning student could perhaps describe any error as a typo. That's not what you mean. I know what you mean. You mean more misspellings and things. Obviously, if your typo means that you've said something that is correctly spelt and false, then I'm afraid that's going to be marked as if you meant it. Otherwise, we get into all sorts of nightmares, like the candidate typed 4, the answer's 3. Do we give it a time? Okay. We have to write these facts in our workings. You can just do the question, I think. Most of them are multiple choice, so you should just do the question. Yes. Should we know the proof? Hey, so I knew this was coming. Here's another circle theorem. It's the one about the angles at the centre. Look, no one can stop you from knowing these things. And now it's on the stream. Thanks to Kay, this one is on the stream as well. So now everyone knows it as well. Good. how relevant a personal statement is. We will look at your personal statement. Sometimes it's got important information in it. Often it just tells us that you're really, really keen on maths, which is good and fine and to be encouraged. But by and large, the math is more important when we're shortlisting. Oh look, people know so many. Maybe I provoked that by saying that I didn't want to have a million circle theorems. Maybe that's how you get chat to give you a million circle theorems. Right, okay. I think the slope is percentage. I think it's worse than that. I think 100% means 45 degrees, which is 50 radians. So I think it's the tangent or possibly the cotangent. I've thought about this too much before. It depends whether you think that they're measuring based on road distance or horizontal distance as the crow flies above the whole thing. You know, if you're driving up a really steep mountain, those are quite different. Right. Ooh, that's certainly an opinion. We always end up talking about gradients at this point. We have a big argument about degrees and radians, and then somebody will mention gradients, and then I have to explain what gradients are so that people don't feel left out, which I'll do now, which is gradients are an invention where there are 400 in a circle, and that sounds like a good idea because that splits into 4. So does 360, but it splits into a 4. So instead of 90-degree right angle, let's round that up to 100. 400 gradients, they're slightly smaller than degrees. If you love factors of 100, then gradients might be for you. It's the other one that your calculator can do. That is calculator free. You got the t-shirt, hooray! Right, okay, somebody's in their gradients, right, okay, I'm really sorry, right, look, okay. Everyone's got their favourite. We're going to look at some revision questions now, I think. So I'm going to scroll these on the screen very quickly for people who are just seeing them for the first time. And there is a vote in chat. How many are there? There are 13 to choose from. Which means I've realised I need to remove all of the options greater than 13. Otherwise, there we go. So chat is going to vote for which ones we're doing next. Here's a quick look. I tried to design these when I originally wrote them. Tried to design the first few to be quite straightforward, I hope, so that if you haven't met vectors, you get to practice vectors. And if you haven't met vectors before, I honestly hope you have another place to learn about vectors. Like something online like Khan Academy maybe, or maybe a teacher or tutor who can tell you more about vectors. The other questions further down are much harder because I'm trying to get you to do questions harder than A level or equivalent. So question 9 is still quite standard because there's a circle, and question 10 has got a bit of work to do. Question 11 is quite a lot of work. Question 12 is quite hard, I think. And then question 13, winning the vote at the moment, is a graph sketch. Have we had a graphs episode? I can't remember. Maybe we've had a graphs episode. So I'll let chat vote a second. Drink some water. Am I missing anything going on in Slido chat as well at the same time? Oh, loads. How can we show the admissions office that we love maths? Firstly, you're showing admissions tutors. Mostly, that's mostly tutors looking at these things rather than sort of some recruitment specialist in the office. It's mostly maths people looking at these things at Oxford, at least. We love maths in our personal statement. I think the encouragement, the prompt questions you're given. Callie's answered this as well. I'm going to read out Callie's reply. Thanks, Callie. Callie says, if you've done anything mathsy, then mention it and talk a bit about how you enjoyed it. If you haven't, talk about which parts of maths you like, says Callie. That's good advice, Callie. I like it. I think the question these days, you get 3 questions. And I think one of them asks about what you're doing in education, and one of them asks about what you're doing outside of education. So it breaks it down a little bit, which might help prompt you to think of bits of maths that you're up to. Occasionally people tell me about them at Livestream, which is kind of circular, here we are, but occasionally people say that they've done some maths. Maybe they scroll back and look at Oxford Online Maths Club, which is also on this channel. So the idea of that show was partly that people might discover their next favourite source of maths. I say your next favourite sort of maths because it doesn't have to be your favourite sort of maths forever. You have multiple obsessions. Okay, right. So 13 is 1. Quick look at the poll on the screen so that you can see this is honest voting. A, B, C, 13, 12, 11 in reverse order, but then 7, which is exciting. Ah, yeah, 7 is a bit weird, and then 10. Okay, so it's the last few questions. Let's call that there, I think. Thank you for all the votes, everyone. Yeah, the only relation between Oxford and Oxford Brookes is that we're both in Oxford. That's mean, actually. We have some connections. Some faculty might collaborate between the two, but from the point of view of the students, they're different universities. What should you write for question 2? Wait, what was question 2? Oh, question 2 wants you to show this on your diagram, which is maybe a bit strange. You already gave me a diagram of some vectors, and the idea for that one, when you're adding the vectors, is that you can draw one, tail to nose, and then draw the second one, starting with its tail at the nose of the first one, and pointing somewhere else. So kind of put one arrow and then follow the second arrow. If you're drawing arrows for your vectors, you do an arrow and then another arrow. If you do that, then you end up at the sum. The sum represents the place you end up after you do both of those translations, one and the other one. Is MAT or interview more important? I think MAT is more important before we shortlist because we don't have an interview at that point, and then afterwards they're both important. And there's not really a number on that because it turns into very anything goes really. Okay, humans making decisions, not computers looking at numbers, but humans making decisions. So at that point, it could be anything. Oh, question 2 for personal statements. So sorry, just said loads of stuff about adding vectors together. I hope that was helpful for someone. Wasn't helpful for you. Question 2 for personal statement. That's the one in education, right? Is that the education one? Yeah, I think it's the one in education, where you're going to tell me probably about maybe the courses that you're doing in school, or maybe other kind of educational things that you're doing. I think people are probably going to blur them together a bit. I think that's going to be fine. I should probably tell you that behind the scenes in Oxford, we'll get these answers to the 3 questions which you've answered, and we're sort of going to glue them together, I think, so that they all appear next to each other. They're not going to 3 different people. So, because last year we had just one personal statement, so this year we would like to use, try and make it look the same. What is a MAT score that would guarantee shortlisting? I actually don't think there is a MAT score that would guarantee shortlisting. Yeah, no, I'm not going to guarantee anyone gets shortlisted. I really can't. It's just safer not to. Am I interested in the matter used in 3D design? Not just measuring buildings, but using fractals and morphogenesis. I mean, sounds fun. Sounds like maths. If we're still talking about personal statements, then I think you're going to also try and connect that to what you're doing, what you would be doing on the course, which involves maybe a tiny bit of fractals, maybe a little bit of morphogenesis if you do the biology unit later on. You don't have to connect everything to what's on the course, but maybe that's part of your why do you want to do this at university, which is, I think, the first question. I'm trying my hardest to remember the 3 questions. Why does that MAT fluency? Yeah, here we go. Why does that going to be a high MAT score not get interviews and shortlisted with lower scores? Because we have other information as well, bluntly. We have other things as well. We don't just have your MAT scores. We have other information too. And I'm not going to comment on specific historic cases. Good. Okay, are MAT questions used in interviews? No. They're similar sort of style, I suppose, but interviews can do follow-up questions as well. We're still on personal statements. Somebody says, am I going to read them? And I'll read some of them. I'm involved with admissions at New College. Yeah, okay. Right, we're going to do question 13 in a second. I wonder if I can scroll so that that's possible. Oh yeah, I can sort of put it there and then put the split. Like that. There we go. Okay. Disadvantage if I have maths and further maths without physics? No, you're fine. We have a requirement for maths, we have a requirement for further maths, we do not mention physics. If we needed physics, or if we had a preference for physics, we would really have to tell you. Like not just via Slido chat on a MAT live stream, we would have to put it as a admissions requirement. We would have to list it as like recommended or essential or helpful on our course page. But we have the options to do all of those, and you will note that we didn't. Right, how much should I focus on my IB extended essay process in my personal statement? As much as you like. It's your personal statement, you can do whatever. The whole thing could be wall-to-wall IB extended essay if you want to. Or you could not mention it at all. Those are both fine, everything in between. I'm not going to tell you how many characters should be on this or that, because it's yours. Okay, right, okay, we're doing question 13 now. Enough chat, I want to do some maths. I haven't done any maths yet, and it's like 5:30. Right, okay, here is the question. Circle has centre C, 0, and radius 1. So this circle, oh, is there a circle tool? Yes. Yes. Oh, it's the solution to my terrible art skills. This is amazing. This changes everything. Right, okay. We've got a circle with centre C, 0. I wonder if that's attached. Yes. Oh, Myro. C, 0, somewhere on the x-axis. And radius 1. Nice. Okay. The area in the region x greater than 0 which is inside the circle depends on C, and we'll call it A of C. And we're asked for a graph, which I'll do over here, C, A of C. So this area depends on C, because as C moves over, as C changes, more of the circle is in the region x greater than 0, until you get all the way up to, what is that, pi, for the area of the circle. So at some point, I suppose when C is greater than 1, the area is just pi, because all of the circle is in x greater than 0. And I suppose below -1, the area is just 0, because the circle hasn't got there yet. Those are the easy bits, I suppose, to sketch. -0 down here, no area. Pi up here, because all of the circles on the right-hand side. And then the question is, how do you join the dots? And I suppose I would be happy with kind of anything that joins the dots sensibly between here. So increasing, because the more C increases, the higher this line goes. If you just draw a straight line, then it's probably not just a straight line, is it? And I suppose there's this halfway point where it's pi over 2 when C is equal to 0. So it's nice and symmetric, I think. There's some rate that it increases at. So as C changes, do you gain a large slice of circle or a small slice of circle? And I think as C changes just a little bit, you gain larger and larger slices. So I think it goes up faster and faster and faster, and then slower and slower and slower on the other side. So I'm going to try and draw something that does this. I have questions. This is probably good enough for question 13. If you drew something like this that's smoothing, it's faster but then slower again. One more time. Faster because as C increases over here, I only gain a little bit of area to do with that kind of slice of area that's just gone in onto that side. But when C is a bit larger, so let's make C a bit larger. When C is a bit larger, if I move C to the right a little bit more, I get quite a large sliver of area. I think I'm imagining that this is one of those round loaves of bread, and I'm chopping slices, and I'm adding them all up because that's all for me. But I'm chopping little slices to make this area. Chop, chop, chop. And to start off with, I'm not getting very much bread, but then I'm getting bread faster and faster as I chop these slices. Until I get to the halfway point, my kind of greediest moment of chopping these massive slices of bread. And then as it goes on to the other side, I'm still chopping away, but now I'm getting small slices again. So the area, my total amount of bread is going up slowly until I get to the whole thing, at which point I have now got sliced bread. Yeah, so questions in chat. Can we integrate? Is it a sigmoid? I think it's not a sigmoid because I don't think it involves any exponentials. Is it sigmoid in a kind of general sense? Yes. Is it precisely the sigmoid graph? I don't know. Let me double check that that's a real thing and I haven't made it up. Oh my goodness. No. Oh no. Okay, I'm wrong. A sigmoid function is any function. And then the one I'm thinking of that involves e to the x is a specific example. So your description in chat of it as being sigmoid was okay. Good. Is it a bit like, Jonah says softmax. I don't really know what softmax is. I'm going to Google that as well and then come back. Or tan. So some of these things, like the ones with exponentials, there are curves like this, like inverse tan. If you think that that's like a tan graph but drawn sideways, those tend to a limit with there's some difference that persists, whereas this one actually hits 1 and then it's flat over there. Right, I've googled softmax does some combination of exponential things and some sort of sigmoid shape thing, I think. Yep, okay. Haven't heard of that one before. I like it though. Good. Yeah, so questions that I have, I suppose, that I don't think we're going to answer today are, what's the gradient over here? Is it differentiable? Can you do a gradient? That's not really a MAT level question. That's a university level question, I think. Possibly at the end of year 13, you might be able to write down an exact formula for that area on the right. Well done if you had a go at it, by the way. If you had a go at writing that down, you might be able to get an exact formula, and then by the end of year 13 or equivalent, you might be able to differentiate that to work out the gradient over there. But I'm going to leave that, I think. I think it is differentiable. Do I? Once but not twice. Because I think it's like x to the 3 over 2. Yeah, I reckon it's differentiable once but not twice. One way we could go is I spend another 20 minutes just trying to work out that function. Different way we could do it is I could just do it. Let's see. So what's this? So we want this area, because it's on the right hand side. How badly could this go? I've got a point in the middle, and this is c plus 1, and this is 0 on the left. So the question is, given that the radius is 1, I would like the area on the right, which I might think about as being something to do with a sector of a circle minus a triangle. That calculation comes up quite surprisingly often, that you have a kind of sector of a circle, curved side on the right there, but you don't want the triangle bit, you just want the bit on the right, in which case if I knew theta, then I would do theta over 360 times 2 times pi, sorry, for the area, but then subtract 1/2 both sides of 1 sine theta, which is not too bad. Not too bad at all. So I might do that. If you use radians, this is over 2 pi, this is 1/2 minus 1/2 sine theta, which is pretty nice. You can feel smug if you're using radians right now, I guess. I also need theta though, so to find theta I would need to think quite carefully about the distance here being c. So that distance, so then theta, yeah, okay, so I'd use some trigonometry to work out that, and it'll be a bit of a mess involving arctan or something. Anyway, okay, good. Should we spend 20 minutes on it? One person in chat wants to spend 20 minutes on this. Isn't a sigmoid a bijection from the reals into itself? I think the sigmoid graph I'm thinking of is not a bijection from the reals into itself. It's like e to the x over 1 plus e to the x. So hard questions in chat today. Right, do I want to do this last part? No, not really. Sorry, if you're excited by doing the rest of the trigonometry, then I'll leave that to you. You can even put it in Desmos. If you do, put a Desmos link in chat. I'd love to see this graph but done in Desmos using your knowledge of trigonometry and theta and all of that. That sounds fun. Right. We can't differentiate with respect to theta because we don't, well, we could differentiate that with respect to theta if we knew how to differentiate sine theta, which is not on the MAT syllabus. And I'm aware that I'm drifting off the MAT syllabus and need to come back to earth. Differentiating it with respect to theta also wouldn't tell you the gradient with respect to c, because you need to think about the derivative of theta with respect to c as well, and that's not obvious at all. 12 is also on the screen. So 12 asks us about 3 points, and any 3 points that aren't collinear, well, they'll be on the corners of a circle. We're asked to find the circumcircle, the one that goes through all 3 points. You are not expected to know the word circumcircle, I just felt like saying it. Sorry, I had a look at the Encyclopedia of Circle Centres earlier this week, which reminded me that there are loads of great circle words, but maybe I shouldn't say them unless... right, okay, let's put chat on quickly. Chat's having a chat. When I said bijection into itself, I meant onto a subset. That is an injection then. Yeah. Right, okay. You've got a definition of a sigmoid function that is slightly more precise than the one I said earlier, because you believe the image should be an open subset of the reals. I think the person before you, who said sigmoid function to mean S-shaped, doesn't have like that extra detail. Not sure if I do or not. The one that I'm thinking of when I say sigmoid function is e to the x over 1 plus e to the x. So yeah, that maps the reals onto an open subset. None of this feels very MAT syllabus though, so I'm gonna just, I think, end this thread here. Sure, maybe sigmoid function has a specific definition. Not relevant right now, I think. Sorry. Oh, Ginger Biscuits had to go at Desmos. That was really quick as well. I'm gonna check it. If it looks good, it's going on the stream. If it's somehow a Rickroll but in Desmos, then oh my goodness, what is this? Oh right, okay, they haven't integrated. This is almost a Rickroll, right? They haven't integrated. They've told Desmos to integrate. So there you go. That's amazing. Just instead of doing the integral, just tell Desmos to do it. They've got a kind of graph which kind of looks differentiable, looks nice. Can't you do over dx? No, that's not how Desmos works. Y prime? No. Okay, looks nice. Hard homework. Maybe for the end of year 13, work out what's going on there. Anonymous has done this as well, as Anonymous calculated it. Sorry, this is now a Desmos live stream. Thank you, Callie in chat, who I think might be trying to. Yes, good. Anonymous in chat has also got Desmos to integrate it. Right, okay, everyone's doing great. Okay. Question 12. I'd forgotten Desmos could integrate now. Oh, I love Desmos so much. Right, okay. Here we are. Here's the situation. We're asked about a circle and probably drawing some lines. Probably your lines went through the points that you drew. There we go. A hard way to do this question is to try to find, so here's a general point, where would this circle be? Maybe it's over here somewhere, x comma y, and try and make all of these lines the same length. This is quite hard. After a while, you find yourself wondering whether there is a simpler way, whether you have like 3 statements involving distances to deal with, 3 expressions for distances that you want to be equal, which is quite tough to deal with. After a while, you sort of wonder whether there might be a way involving maybe finding some lengths of those lines. Is it an isosceles triangle? Is there anything special about this triangle in the question? Because if it's a nice triangle, like if it's an equilateral triangle, then the answer is just it's in the middle. If it's, that's the best one I know. If it's isosceles, then I guess it's on the line of symmetry, which would be not nothing. And the hard way turns out to be nice, says chat. That is a good way to trick me into doing the hard way, isn't it? And Anonymous in chat says that the sides are perpendicular. They've spotted that these things, there's a right angle hiding here. And once you found the right angle, well, okay, I'm not expecting you to know where the center of the circle that goes through the corners of a right angle triangle is, but it's something you can think about. You could draw a picture with a right angle and a circle in it, see what happens. Also, if that's a surprise, which probably is, if you haven't got the right angle there, you might have to think about why is there a right angle there. Meanwhile, I'm going to do this the hard way. So, what have we got? We want x squared plus y squared. That's one of the distances, okay, squared. We want this to be equal to x minus 1 squared plus y minus a squared. And for that distance, the radius squared to be equal to x squared plus y minus a minus 1 over a squared. I know that distances have square roots on. I've squared both sides. In an A-level question, I think I would now lose a mark for not showing my working, but hopefully talking to you, you'll allow me to just skip that step. We'll find out, I suppose. So this first one's not too bad, is it? I suppose the x squared and y squared terms cancel on both sides. There'll be an x squared from this bracket and a y squared from that bracket. So what do we have? If you've just joined, I said out loud that this would be a bad way to do the question. Chat said it's fine. I trusted chat, and now I'm doing the question. I hope I don't regret this. Oh, this is really good. This x squared just cancels. The y squared over here cancels as well. So I get 2y over a, and I get 1 over a squared. That is good actually. That gives me the y coordinate. And then once I've got the y coordinate, I think the x coordinate magically turns out to be 0. Yeah, nice. Did this actually rearrange nicely or something? In chat, somebody's given me a formula for y. Solve the second one without expanding. Oh, solving the second one without expanding would be very clever. I wish I'd thought of that before I just expanded it. They've cancelled the x squared and then done something much more clever than expanding. They saw that I was about to, and they say you could just do sort of square root stuff. Either, right, yeah, whoops. Didn't understand it. I'm setting loads of distances equal to each other. If you're not following this, I don't recommend trying. That's an unusual statement, isn't it? I think this is a complicated way to do the question, which I'm only slightly enjoying. I'm enjoying it a bit though. Is this going to cancel out? I'm hoping that x is 0. I did the expanding squares thing over here to get this statement. And I'm hoping that I can say, so x is 0 from this one, but I can't quite see it. That's a bit cheeky of me to just write my conclusion over there, but I'm going to try and check it. So I'm hoping that 1 plus a squared, take away a times y. This doesn't look true at all. No, something's up. Something's up. No, maybe I'm good. Maybe I'm good. What have I done? 2 ay in here from expanding the square correctly. Thank you. So then after plugging this, multiply by 2 and by a, you get a squared plus 1 with a negative sign, which cancels out this a squared plus 1. So x is 0, which means that the center is halfway up this bit of the y-axis. It's right in the middle. This was a diameter all along. And chat, someone says, how do you know the y-axis is the diameter? Aha! So once you found this right angle, by working out that the gradient here is a, because you go 1 across and a up. Gradient is a divided by 1, rise divided by run. And then the gradient of this bit is minus 1 over a, because, well, reading left to right, the rise is negative 1 over a, it's gone down, and the run is 1 again. These gradients multiply to give minus 1. Because the gradients multiply to give minus 1, there's a right angle. And then because we have a right angle and we're being asked about a circle, should draw in a circle, really, shouldn't I? Here comes the circle. Let's try and get a good circle that can plausibly go through all 3 points. It's not perfect, but it'll do. It's not perfect at all, but it'll do. The centre of this circle, well, first let's look at the picture. We've got a circle, we've got a right angle, this is a diameter. Using that fact that I highlighted earlier, foreshadowing, with the angle in a semicircle is right angle if AB is the center diameter of a circle and C is on the circle. Wait. If AB is the diameter of a circle and C is on the circle, then angle ACB is 90 degrees. I guess technically I'm using the converse of the fact that I read out earlier, but I'm hoping that I get away with that to say that this is the diameter and the center is halfway up. Or do some algebra, which turns out not to be too bad. Not to be bad. The person in chat also says it seems awfully convenient, and that's because, well, I wrote that question to look really bad. In general, finding the center of a triangle is pretty hard, but for you to be able to feel clever by using facts from a limited syllabus of revision material, I might enjoy it. And then question 11 is the other one that got requested by quite a lot of people. Question 11 gives you 2 circles and asks for the intersection. This is, I think, slightly easier if you've just done question 10. A strategy you could use is to split it in half to join both of these to the centre, and to think of this bit of area as being a sector of the circle minus a triangle, where I think you know where everything is. I've marked these centres over here, but I think you know better than that. I think you know where they are. So you can probably draw a better diagram than this. Mark in lots of points, find as many distances as you like, find as many angles as you like, using possibly the cosine rule. Next week we'll look at the cosine rule together. And then if you follow all of that through, breaking the problem down into small parts, you'll be okay. Yeah, I think it is the same situation as question 10, because I think you do get an angle of 120 degrees at some point. So well done if you managed to use your answer to question 10 to do question 11, which is not quite on the screen. There it is. 10 and 11 kind of go together. Right, yes. Anonymous in chat says each centre is on the arc of the other circle. So it's not quite what I've drawn. This point is supposed to be here. Which is kind of cool. And that centre is, I've drawn a very wide circle over here. That's supposed to be over here. Which means that hang on, so the radii are 2, and so marking 2 and 2 over here, and the distance between these centres is also 2, and it's all very symmetric, isn't it? So I can put in a 1 here, and now I think it's clear that that is 120 degrees. And I'm being asked about that region over there, allowing for this 120 degree angle chunk. It's not too bad. 120 degrees is 1/3 of a circle, and there's a large triangle there, but I think you know it's got width 1 and height twice the square root of 3. So I think you're probably right. Anonymous in chat says, maybe an all-timer chat comment. Don't act like you didn't just make up the word orthogonal. Sounds like a Harry Potter professor. Yeah, people say orthogonal to mean at right angles too. It's a whole thing. Synonyms, eh? What are they like? Alright, what's the final answer for question 11? I think it's 8/3 pi minus 2 root 3, which has come from a bit of the pi bit of that has come from, well, 1/3 of a circle doubled. The circle has got radius 2, so it's got area 4 pi. 1/3 of that doubled gives you the 8/3 pi, and the minus root 3 bit has come from, well, I want to subtract this triangle. Now we're doubling up because I want all of the region inside this intersection bit of the Venn diagram. That triangle is 1/2 of 2 times 2 times cos 120, sine 120. Oops. So we should be all right. Oh, it's we agreed already. It's width 1 and height 2 root 3. Possibly just root 3. Possibly just root 3 overall. Yeah, and then doubled. Good. So this bit is 4/3 pi. Minus root 3. We want to double that. Because we're actually interested in, sorry chat, we're actually interested in all of the middle stuff, including both sides, left and right. Yeah, Hugo in chat underneath, did you see he wants to use the scalar product? Which is a bit more advanced than the math syllabus. But there you go. In some sense, the scalar product is just, it's quite hard to stop people from being able to use it, right? Given any two vectors, you can always, if you know about scalar products, you can just go for it. Oh, very stuck on question 12. How did I set up the equations? So if you want to do the equations, I'm thinking about the distance from the center to each of the points. So I have things like, in my head, x minus 0 squared plus y minus 0 squared square rooted. That's one of the distances. And then I have another distance, x minus 1 squared plus y minus a squared, to say, well, I don't know where the center is, I'm calling it xy, but I can still write down expressions for these distances. I kind of have them all in my head or ready to go, I suppose. The things I've actually written on the board are a bit simpler than that, because while thinking about these, I mean, I don't want to write down minus 0 unless I have to, some sort of A-level situation. And I don't want to write these square roots. These are equal to each other, so their squares are equal to each other. So I've chosen to just write down x squared plus y squared. I want these lengths to be equal so that I have a center of a circle, all of these points lying on the circumference of the circle. The thing about a circle is everything on the circumference is the same distance from the center. You can use that property to find the center if you have enough information, because the center has to be the same distance from all of the points that are on the circle. Yes, so I can set these equal to each other. Yes, I haven't given you the property of a circle that every point on a circle is the same distance from the center. Sort of defining property of a circle, really. Yes. Okay, so then I've got these equations that just come from setting these things equal to each other, and squaring, and then multiplying out, and then algebra. Off we go. Off to the races. At least I didn't say orthonormal. Yeah, true. I thought about saying orthonormal, but then I didn't. Yeah, so these are expressions for radii, and they're all equal. Good. Okay. Let's have a very quick look at 7, because there were some requests. 7 asked you for 3 lines, such that the finite region bounded by the 3 lines is an equilateral triangle. And there are loads of choices that you can make for this, to draw 3 lines that give you an equilateral triangle. Loads, because there are loads of equilateral triangles. To make my life easier, I think I would pick maybe a horizontal line. You could have a vertical line if you want to, but not both. And I would try and find points with hopefully a predictable gradient. Maybe I would make this be the origin, just to make my life easier. And I would work out where these corners are. I mean, maybe this is 1, 0 to make my life easier. And then try and work out where this point is, based on the fact that this is 1. So it's sort of halfway along, because equilateral triangles are nice and symmetric, and this is that's not marking 1, 1's over there. Halfway along, and I suppose root 3 over 2 high. That's how tall equilateral triangles are if they have side length 1. And then I would write down lots of equations to go through pairs of points. I suppose one of them is y equals 0, and one of them is not too bad, but then this other one is a bit worse. It's happening. This is the thing. Oh, one of them is this one, but then the third one is a little bit worse, because it has gradient minus root 3, to lose that root 3 over the next half. It's happening, isn't it? Oh no, it's not too bad. I can just do that. And then no one can accuse me of not writing minus 0 on either side, right? No one can accuse me of not writing minus 0. A-levels apparently are, I suppose, for social. I'm learning so much about A-levels, this is good. Anonymous in chat wants to make the center of the bottom origin. the origin. That's certainly a choice that you're allowed to make. I also would maybe consider making the top corner the origin. Everything goes a bit negative, so maybe you might do your equilateral triangle this way up. It's a choice that you can make, so that you get lines through the origin are slightly easier to write down, and then this is some sort of horizontal line up here somewhere. Maybe that's the easiest way to do it. There are many, many choices. Okay. Ginger biscuit is made at Desmos. Can have a look. It's not twice differentiable. Was it like 3/2? I used a version of this as an interview question once. This thing that we're talking about in chat about. Yeah, I was hoping for some arc signs, something like this, using some like year 13 math stuff, right? I was hoping for a big stack of arc signs or something, and some square roots maybe. Definitely some integration has happened here. There's a graph, pretty nice. So then you formatted it so that I think I can do this. To get the gradient looks like a circle, sort of. And then the second gradient is going to explode, isn't it? So the second gradient explodes near there. Second gradient, second derivative. Cool, thank you. Oh, while I'm in Desmos, I think I've got, from last year I made a demonstration of this for all triangles. Let's see if I can find it with some sliders. Triangles. Yes, all equal triangles. It's a bit trippy. There we go. Okay, I'll put the full screen for a second. There you go. This is Desmos demonstrating 3 straight lines that give an equilateral triangle, but just running all the coefficients I had at different rates. There you go. So this is taking, I think, an arbitrary gradient for one of the lines and arbitrary constants for where to put the corners, I think. Yeah, something like that. Oh no, it's my three lines, and then I've got, yes, relationships for the other 2 gradients. But these 3 lines are mx plus c formulas, red, green, and blue. If you'd like that. I'm putting this in chat. Somebody is just joining in chat halfway through, watching at double speed. At some point, I mean, it's looping and it's not exploring full parameter range, but this should be able to do all of them. Right, any equilateral triangle your heart desires in the XY plane should make it through. Right, is Callie going to approve my chat message? Let's find out. Thank you, Callie. Right, okay, welcome to the show. I'm at 6 o'clock. We're about to start doing some actual MAT questions. We've got some of them lined up in the worksheet. You can get a copy of the worksheet on the MAT Live page. Oh, I just did a proper spin round. There it goes. We've been doing some revision questions, including thinking about this one with all the equilateral triangles made in 3 lines. Maybe your solution is one of those. My computer is making a funny noise, so I'm going to turn that off. Sorry, computer. And we are going to cut back here. Good. If you've been looking at a screen for the last hour, remember to look away from the screen. Blink, drink water. Remember you are human. There are other things in life as well as maths. And then time for maths again. Right, here we are. I thought we'd do a couple of short questions and then chat's choice of long questions. There are 2 on this problem sheet, which you can pick between. But I think we've got time to do some multiple choice questions. Can I have chat suggestions for how to approach this one from 2016? We've got a circle, although it doesn't quite look like the normal way of writing a circle. So x squared plus ax plus y squared plus by equals c. We're asked whether or not the origin lies inside the circle. Well, actually we're asked for values of c such that the origin does lie inside the circle. Approaches in chat, please. What would you attempt for this sort of question? First one off the blocks is Jacob, but I'm going to give it a moment for other people to let me know as well. If everyone says the same thing, then that's quite, I suppose, encouraging. Cool, okay. Everyone's saying pretty similar things. Yeah, pretty similar. Lots of people want to complete the square, which is, I think, a strong idea to find, I suppose, the centre of the circle. So maybe this is me being lazy again, but I would like it to be completed, and I'm willing to add stuff at the end of the equation to make it true. Okay, maybe I should have put minus a squared over 4 and then move it on the right hand side. I'm learning that gets you marks at A level, but something like this, that's not too bad. And then you have an equation for the radius squared. So you know this is the square of the radius. You know the centre. So you're kind of off to the races now, aren't you? You know where this circle is in terms of A and B, and you know its radius in terms of A, B and C. And your question is something like, is the origin inside this circle? Well, I'm pretty sure that just depends on how large the circle is and where the centre is. And those are the two things we know, so we should be okay. This is a strategy that works. Inequality, yes. Yeah. K in chat, I think 4s instead of 16s. Yes. We should check that this is positive, I suppose. We'll remember, I think, that we need this to be positive. If our final answer includes some cases where this is positive and some cases where this is negative, then we've got to refine that down to just the ones where this is positive. There are some other suggestions in chat. The leading other suggestion, other than this strategy, which, just to finish the idea, is to find the distance to the centre, which we know, and compare it to the radius, to say, is the distance to the centre less than the radius? Like this, question mark. But there's this alternative suggestion that we can just change the equality into an inequality if we think very carefully, or think about when is the origin on the circle, which is easier. Like inside the circle, you have to think about which side of the circle is the inside, but on the circle, we have an equation for that. Points on the circle are given by that equation up there. And the origin is my favourite point to plug into an equation like this, because the origin has x equals 0 and y equals 0, which I will happily plug into an expression like this. 0 plus 0 plus 0 plus 0 equals c. So big fat nothing on the left and c on the right. Oh, have I missed some minus signs? I have missed some minus signs. Thank you, chat. The minus signs that I've missed today are over here and here. Whoops. Yep. Note to self. Formula for a circle, x minus a squared. Variables are allowed to be negative numbers. Yeah. Thank you, Grace and Anonymous, for simultaneously typing sort of the same thing. There's a rather beautiful symmetry for the two chat comments that came in at the same time. One says is the centre, not is, and one says isn't the centre this. And those are kind of different, but kind of the same. Nice. Okay. I guess there are two more. Like, is the centre this? And is the centre? Is this the centre? Yeah. Okay. Sorry. I'm distracted by form. Right. So when 0 is c, or more rolls off the tongue better if I say when c is equal to 0, the origin lies on the circle. So you might expect that to be a kind of threshold. That as you change c, for negative numbers one thing's true, for positive numbers a different thing is true. Now of course be careful with that way of thinking, because you can get caught out, if that's your way of thinking about all parameters, then you can get caught out by things like, well, just totally separate, but the graph of y equals x squared, if the question says when is the graph of x squared negative, you might think, aha, I'll just check when it's 0 and then that'll be the threshold, right, for when the graph of y equals x squared switches from outside to inside, right? Okay. So I'll find out when it's 0, it's 0 and 0, when x is 0. So maybe the answer is when x is positive. And of course, that's not true at all. The correct answer is never for that kind of separate question about y equals x squared. So if you're going to use this method for a problem where it matters, then I would encourage you to think about the behavior as C changes. To think about what happens when C is a little bit positive and a little bit negative. But for this question, I think you can get away with it by saying that's independent of A and B. I reckon it's just when C is greater than 0, option A. Jonah missed a minus sign. No, Jonah maybe had the correct minus sign, but crossed everything out because their minus signs didn't miss mine. Sorry, Jonah. Sorry. We've both learned a lesson today. I've learned that I'm not very good at minus signs on variables, and you've learned not to copy my minus signs. It's only the first math question back from the break. This is amazing. I'm learning so much. It is also true that if you just take that equality at the top and you just change the equal sign to an inequality, you have to get it the right way around, but we'll just change this one, yeah? Inequality instead. This is what Ginger Biscuit says in chat. Then, bet I can come up with a question where that's not the case. In which case, we should do this properly, and we should think about this, right? So if you simplify this inequality, it does turn out to be when C is positive. Good, okay, next one. Here is a question about, this is not quite going to fit on screen. There we go, that's just good enough. So for all theta in that range, here's the equation of a line, and it's not the way that I like to write lines, but to each their own. Y minus 1 times cos theta is x plus 1 times sine theta. And it's talking about the disk with radius 2. So I need to draw a circle, and I've remembered that there's a tool for that. Pop. Oh, love it every time. And I have a straight line. And what can I say about this line? A of theta is the area of the larger region.
Sorry.
That's right. No, sorry. You come back. Sorry. I have a sign and everything. So A theta divides this into 2 areas. Sorry, chat. So chat is keen at the moment to divide by cos theta to get tan theta on the right hand side. That's a thing you can do. It does give you a tan. What's that doing? So tan theta is interesting to me. I think tan theta turns out to be the gradient of this line, which maybe gives you a clue about what theta's doing. I think I want a picture. I think I want some points that are on this line. Yeah, so someone just came in. I have a sign on my door that says, "Please don't come in, I'm recording." And somebody stuck in it. Somebody popped in to ask whether I wanted the office cleaning, to which the answer is kind of not right now. The office is fine. Good. Right. I think I'd like a point that's on that curve, or line, or whatever. I suppose when x is... Because I write my equations like this, so dividing by cos theta is interesting to me, because then you have something like... and then I sort of want to add the 1 as well, because now this is starting to look like the way that I write the equation of a straight line, right? It's looking familiar to me. Maybe it was already familiar to you. So then, yeah, if you put in x is minus 1, you get y equals 1, and that's a clever thing to put in because it's independent of theta. So minus 1, 1 is somewhere over here, isn't it? This point is always on the line. Dot. No matter what the value of theta is. And then I suppose I want to think about I suppose I want to think about what's going on as theta changes. So if theta equals 0, then this is just the line y equals 1. If theta, what else is easy? So I've got this tan theta now. I'm a little bit nervous about the fact that we divided by cosine. I'm especially worried about putting in pi over 2. I'm especially rewind. I'm especially worried about putting in 90 degrees. Especially worried about putting in 90 degrees because that's precisely where we divide it by cos theta. But I think it's okay. I think x is minus 1. That doesn't really make any sense from this equation, so I'm going to put it in here. If cos theta is not 0, we have. And then technically for the cos theta equals 0 case, I should go back to the original thing, which now says 0 is equal to, oh, okay, x is minus 1. Yeah. Oh, so we could try and find out what's going on when y is 0. That's certainly a thing we can work out. I've rearranged it kind of a bit wrong for that, haven't I? I can think about what's happening when x is 0, in which case it's tan theta plus 1, which is fun to think about. Tan theta plus 1, what does that do? Starts at 1, I suppose. Tan theta plus 1 starts at 1, increases faster and faster until at pi over 2, until at 90 degrees, until at 90 degrees, there's no point because it'll rush off up to as far as you like, very large, which corresponds to this case. Theta is equal to 90 degrees. And now I sort of realised that I've gone from theta equals 0 to 90 degrees, and it's also turned through 90 degrees, so at some point... Oh, if theta is 90, how is x equal to minus 1, says Grace in chat. Well, this equation won't help you because we divided by cos theta. And if theta is 90 degrees, that would be like dividing by 0, which we should not do. So step back and look at the original equation, which is in a nice form. Before we did any division, if you put 90 degrees in there, then on the left, that cos theta will be 0, of course. I'm not suggesting we divide by it, leave it alone, 0 on the left-hand side. And on the right, it says x plus 1 sine theta. Or in fact, sine theta is 1 because we've plugged in 90 degrees. So that reads x plus 1 is 0. Vertical line, x plus 1 equals 0. Yeah, so tan 90 is not okay. And it's related to the fact that I shouldn't really have let chat divide by cos theta. Who was it back down here? Or cos 0 maybe, or cos theta. Divide, so it's an anonymous person first, I think. Divide everything by cos to get tan on the right hand side. I should have stopped them there and said, oh, not if cos theta is 0, right? Shouldn't divide by 0. No, wait, cos 0 is fine. I think you mean cos theta though. But, okay, back up. Right, good. If you've got something where you're worried that some of the terms are infinitely large or undefined, I suppose I should say, maybe it's the case that you can step back, because maybe it's the case that earlier you divided by something that was perhaps 0. Stupid example with algebra. You're trying to solve x minus 1 is equal to x squared. What am I doing? And you decide to divide by x minus 1, so you get x squared plus 2 is equal to x minus 1. And then you think, well, what's going on when x is 1? Because this thing is not defined when x is 1. I don't really know what point I'm trying to make here. Sorry, because the right hand side is 3. I should have picked something where x equals 1 is the solution, or put a y on the right hand side. But actually, dividing in general is dangerous, because you might be dividing by 0. We should check. Anyway, I haven't done the question yet, have I? I think this thing is rotating around. I think the gradient tan theta means that, I'll draw a little triangle, but in general, if the gradient here, well, hang on, I can do better than that. The gradient being tan theta means that the point where you cross up here is 1 plus tan theta, which means trigonometry, this is theta. Maybe too much trigonometry today. Next week is trigonometry, but hey, here we are. at this point up here, if you put in x equals 0, I've decided to care quite a lot about the y-axis. I'm going to draw the x-axis in as well. It's quite a lot of lines now. And at the moment, all of them are at particular angles. But we've got a general understanding now, I think, that as theta changes, this line rotates around. It starts horizontal, it goes round, and then it keeps going. The question says, well, something about a of theta, chat is over the top, when a of theta is the area of the larger region. So I'm supposed to imagine, I'm going to clear it all out now, I think, now that we've got a better understanding of what's going on. Can I erase things, or is it going to erase the circle? Ah, perfect. Erase particular things, but not everything. Good. As we change theta, it's going to change the angle for the gradient of it's going to change the gradient of the curve, because it's tan theta. It's going to make this steeper and steeper. The area of the larger part, that's tough. I don't want to calculate it, because calculating these things with sectors of circles is quite hard work. You've seen that already. But maybe I want to draw a little diagram, because in a case like this, where the origin is over here, the area on this side seems to me is something to do with the height of this cap. I've noticed that from a side it looks like a kind of person wearing a hat like this. So we've got this kind of cap bit at the top. I'd like the area of that thing. I'm not going to find it really, but I think it depends on the height here, right? Of the height of the cap. Which I suppose I know lots about, because I'm realizing now we can say things about the radius. We know exactly where this point is, and we know the gradient. So maybe we can say when is that maximized or minimized, just by our understanding of what's going on. I think the angle 45 degrees is important. Interesting choice in chat. Interesting. Think about that in a second. So in my head, this is rotating around, and the size of the hat is changing. H for the height of the hat. Trying to work out how much algebra I want to write down and how much I want to just say out loud. Maybe we want the axes in again. So the intuition here is that the maximum area occurs when that dotted line goes through the point. Maximum area for the large side, not for the hat side. I'm trying to think of a good way to justify that. It's sort of like, yeah, so it's sort of the way that this distance down here is at most as much as this distance out to the point. That's sort of the furthest out you can go. So if I'm trying to maximize that, then I want to take this line so that this kind of perpendicular point is actually the same thing as this point here. There's a right angle triangle here where I have a fixed side, and it's the other side that I want to make large. And because it's a right angle triangle, that side is not the hypotenuse, the way you maximize it is by moving the point so it gets really close, so that you have a triangle with two sides almost the same length, which means putting that point over there. There's another case though, which is that so if you add 180 degrees, and someone said this in chat a couple of minutes ago, but if you add 180 degrees, then you get the same line. That's kind of annoying. I've just about convinced myself that there's a unique maximum, one value of theta, but adding 180 degrees, well, tan has a symmetry, doesn't it? Adding 180 degrees to theta will give you the same line. So this has to repeat every 180 degrees. It's different lines for every value of theta up to 180 degrees, but then all the lines get repeated. So it happens twice in the range in the question. Partly because the range at the very top of the question is not quite, I mean, it's all about that really. And lots of questions about angles start in the range 0 to 360. But here it's sort of, that's almost the thing. If it said 0 to 720, the answer would be 4. It's just, how many times does this thing repeat itself? So after some thought, I've decided that I want tan theta to be, what am I doing? I want tan theta to be 1. Which looks like it's come out of nowhere, doesn't it? But I want this case where we're at 45 degrees. So that the hat is really small, because this line is really long. This line being the kind of perpendicular distance to the line from the origin, which is maximized when that is actually just the distance out to that point. It's the, from here, C to O, is something like the perpendicular distance from the origin to the line, the minimum distance from the line to the origin. The minimum distance from the line to the origin is at least as much as the point distance from a given point to the origin. Right, okay. Yeah, so it reaches infinity and starts doing things again. How do you do it without dividing through by cos theta? So without dividing through by cos theta, I think you can still spot that theta tells you about the kind of rotation of this line. I mean, you might do that by realizing, well, I think you have to realize that -1, 1 is on the line, but then you might try and find another point, right? You might find the point when x is 0. You might ask yourself, where does it cross the x-axis? And am I going to divide by something to do this? Maybe I'm going to divide by something to do this. Yeah, I think I am going to divide by something, but only for a single point. So maybe that's okay. Yeah, because I want to write. Y is equal to, yeah, I'm going to divide by cos, obviously. Okay, I divided by cos for that one as well. Can I find a point on this line that doesn't involve division? There's a challenge. Yes, I can. So -1 plus cos theta, 1 plus sine theta. That's a point that definitely lies on that line in the question, because I've put a -1 and a 1 to cancel out the 1s and -1s, and then I've tried to make the sides equal by making the things in the brackets cross multiply to give cos theta, sine theta 2 different ways. On the left, sine theta in the bracket, cos theta. On the right, cos in the bracket, sine theta. Multiplication is commutative. So I think that's another point. And that one's fun because I haven't really fixed its x coordinate or its y coordinates. But now maybe I can draw the triangle. And the triangle has got cos theta over here, it's got sine theta over here, at which point we are maybe happy that this is theta for the angle that it's rotating by. There you go. How do you do the question without dividing by cos theta? Maybe like that. Find a second point if you're not allowed to divide. Find a second point that's on there somewhere. Anonymous in chat says you can instead divide by sine theta. That is a similar approach. It has issues in other places. I'll put their message on screen so that you can read it. Good. I'm not sure if you can tell what happened there. What happened there is I got distracted, first by someone coming in, but then second by thinking about a different way to do the question. What did I write down on the solution? Aha, I just claimed it out of nowhere. Not even 45 degrees. 135 degrees in my solution. So one of us is wrong. I don't want tan theta to be 1, apparently. Wonder why not? It'd be fun if my solution is just nonsense. 135? Yeah, 135 seems wrong. I think 45. Red pen. Check this. Okay. Sometimes we make these better. Oh yeah, should we Desmos it? That sounds lovely. Good suggestion. Let's do some live Desmos. Oh, I can't do a geometry live stream without doing some live Desmos. So the question was y minus 1. Because I think this works. Yes, it does work. Although possibly Desmos has got strong feelings about what theta means. Oh yeah, that's no fun. Okay, we're going to go for A. My standard slider variable. There you go, there's a line. And we're also asked about the circle x squared plus y squared equals 4. And we get us a little slider here for 0 to 360 degrees. So as we change the slider, the line rotates. The thing that we've discovered is that minus 1, 1 always lies on here forwards only. Thank you, Desmos. And while we're here, degrees. I'll put 360 in here to keep me happy. There we go. So as it rotates, there's a large area and a small area, and I think I've accidentally got in my write-up for the web, I've put 135, but I think that's a waste. I think that makes the large area the same size as the small area. Just missed potential to make it, make the large side slightly larger. There is a weird property going on here that the sides of the line swap as it turns round. Which side is which changes. So that's fun. Wonder if I can shade the region. But 135 maximizes the area of the smaller area. Yes, true. Okay, I think I've got a false fact. For the 5. I found the minimum. Okay, yeah, there we go then. Wonder if I can highlight. Maybe I'll leave this as a Desmos challenge or something. Highlight the area that we're talking about. I just want to do it now. I guess it's not always under the line. It's the side that includes the origin, maybe? Maybe we can use that. I want to highlight the two regions, possibly in the correct colours, with the colours swapping when the two things swap at that moment. I'm not going to Desmos it live, I think. Would I do it like that? Yeah, I think I would. So it's like on one side of this. But then which side, right? So you could do this to get a side of this, and you could take inside the circle. That's something you can do in Desmos, I think. Less than 4 to get inside the circle, to get one side of this. I wonder how that changes in Desmos. I haven't thought about this at all. As I move this round, does it stay on the same side? Yeah, so that stays on the same side consistently. It's not always the largest side though, small and then larger. There we go. And the other side, which is here in red. So sometimes it's red, the red bit that's A of theta, and sometimes it's the black area that's A of theta. So maybe I should switch the colours around. Okay, well, let's save that for another time. What is this? Cool, right. There were 50-50 chance whether Desmos would flip it halfway around. Essentially, when something like tan theta goes through infinity, it's anybody's guess what Desmos will do when it comes back on the other side. Is that an opportunity for it to now be a very negative number, or is that happening on both sides of the equation, so we're okay? Who knows? Right. Don't you need to find the points where this line intersects the circle and then find the angle for which the distance between these 2 points is the smallest? I think you could. That sounds like quite a lot of work. I'd prefer. I'm getting happier thinking about these distances, actually. Thinking about distances where I've got my perpendicular line, a radius pointing out to this line, which is at right angles to the line. Find the radius that's right angles to this line. Ask yourself how long this bit is. It's at most that length. Look at there. No, I've become happier with these distances. You're welcome to do angles if you want to instead. Right. I think we might skip the next short question. We've got 25 minutes. So what I'm thinking, we'll have a quick look at it on screen, just so we've had it on screen. This point asks about a reflection. It's from 2014. I've included it on MAT Livestream as a kind of calculation for you to do. You're not expected to know this. I think some people learn this at some point during A-level, depending a little bit perhaps on what order you're doing A-level in. You might have already seen it. But I would do this by finding distances. So if you're interested in how to do this calculation, I would essentially do it using normal maths techniques like this. I'm looking for this point over here. It's mirror image. So I think a way to get there is to find this point, which is like looking straight at the mirror. So to find this point where this is a right angle, and then, well, which I would find by using the fact that the gradient here is -1/m, because it's at right angles to y = mx. Oh gosh, that's not enough facts though, because I need to send it through this point as well. So I guess it's y is -1/m, x -1. Oh gosh, and then I would maybe find this distance, or find this like x coordinate, and try and go similar triangles, try and go twice as far. To go sort of twice as far, because your reflection is on the other side via a right angle perpendicular line, and it's the same distance from the mirror as you are. So I'll try and do some similar triangles or something, double this up. I haven't found this point yet, because I need to do some intersections. Yeah, okay, right. Suggestions about which long question to do. I think this is a lot of work for this short question, and I worry that for some people it's just something that you've seen, which is not really you demonstrating problem solving so much as demonstrating memory. I think there's a formula in the booklet. Maybe 10 years ago there was a formula in some people's formula booklet. Told them how to do this. Right. Yeah, so Rosie says, using the formula, there you go, inserting the x value for each only d and e and get the corresponding y. So there's some sort of formula that Rosie knows, right? And Rosie's only finding the, only looking at the x coordinates. Or maybe only the... Yeah, it's an interesting question whether you can work it out from the options going on here. And semi-interesting question to work out what the other options are. Oh, the simple one on screen. Oh, this one. Wait, what? You're doing my question. Nah. Ah, inserting the x value for each. Ooh. Oh, you're checking whether the 5 points in the question. You're checking whether 5 points in the question lie on this line that I've already got. That's pretty good. That's pretty good. Eliminating options. Only D and E are actually on that line. I'll give the corresponding Y. Huh. Now I want to know what the points are. Sorry everyone. We've now got a question about M. Why do I even close Desmos? Oh no, this is going to be a little bit tricky. Talk amongst yourselves for a second. We're going to try and work out what these other points are. Oh, no, we're not. Some of them are just minus signs in. It might look cool though. There's a chance it looks cool, and this is all justified. So we've got a point 1, 0, and we're trying to reflect the purple point in the green line. And the options that we have, some of them look like this. No, we're not on screen. We're not on screen at all. Now we are. Some of them look like this, and then the second one is just 1, m, which is on the line, so that looks a bit unlikely. 1 minus m, which is a bit too simple, I think. Something with some minus signs in. Oh, this is the reciprocals of the first thing that I wrote down, and then 2m over here for some reason. And then e is 1 minus m squared m. And Rosie's observation, I think, is that if you find this line, which is perpendicular to the green line, I've typoed something, haven't I? So I'm just going to 2m over m squared plus 1 down here. If you find this perpendicular line, there we go, only 2 of the options lie on that perpendicular line. So looking at the mirror, you only see 2 of them. The others are, well, gosh, one of them's on the line. One of them's on the line, and one of them's on the wrong side of the line. And that blue one is maybe plausible. It could possibly... Ooh, there's a special case where 3 of these are all the same. That's kind of interesting. The rest of the time I'm not that interested. Oh, that red one goes off to infinity and comes back again. You see that happening? Back in again. Just an example where there might be some division by 0 going on. Depending on what this line is, the bisector is somewhere. They've made sure that 2 of these points lie. Oh, I could change that on fun. 2 of these points lie on that perpendicular line. Only one of them is at the right distance, though. I would prefer to think to do this with distances and things. What does chat say? You could sub in m as 0, 1, sort of pretend it's infinity to get the answer. Oh no! Okay, special case. Special cases. You're allowed to look at those. Okay, so I've seen one anonymous person ask for the first long question, and one anonymous person ask for the second long question. Ginger Biscuit would like me to have another look at this Desmos chart. It's actually, due to a Desmos update, the same URL that it was before. Ah, there you go, you got the colours working. Do they switch around? Yes, they do. Well done. What's this folder that says things? Ah, loads of things. Well done. Does it just render both and swap? Yeah, you've got you've done the thing I thought you would do, which is to hard code the limits. Oh, you're actually swapping the colours rather than the regions. That's a good idea. Right. Cool. My computer is quite upset about running Desmos, so to try and placate it, I've closed Desmos, and it is making more noise now than it was a second ago. Right. Can I do this? We're going to have a quick vote. We've got 20 minutes, and we're going to have a quick vote for whether people want to see the first long question, which looks like scroll plus all the hints. Looks like this, it's the one in the thumbnail, or whether people want to think about the second long question, which is, I think, much harder and has triangles and circles. Why am I doing this like this? Okay. Triangles and circles, shown here with 2 different heights. This question looks really tough, but actually you kind of know where everything is, so it's not that bad. And it has a really horrible bit about a triangle for kind of almost no reason in there. That is a 70-30 split based on about 10 votes. So I think I'm leaning towards the second question as it currently stands. I'll give you a second to have your say as well. They do. Will's noticed that. Look, I'm just going to call out something really quickly because this is not a math thing, but Will has seen 1 minus m squared over 1 plus m squared and 2m over 1 plus m squared somewhere else, involving tan half theta formulas, I think, or possibly some double angle stuff. There's something going on there to do with reflections and double the angle. I would encourage you to explore it. we already had a clue earlier in the episode that tan theta and gradient are linked together. The gradient here is m. You've seen something with tan theta, I think. So try doing that substitution and see what happens. The vote's really closed in. I regret trying to. Oh dear. Oh dear. What are these percentages? Oh, I've allowed you to vote for both. How is the first one now winning? Yeah, you can vote for both. So, although voting for both is a bit like voting for neither. I guess it increases engagement. Okay, the first one's now winning, so I guess we're going to look at the first one. Let's see if we can look at the first one kind of fast. Well done, people voting for the first one. Oh, it's going to tie again. Okay, we're stopping it. Excellent percentage work there, everyone. Is there a particular part of the first bit, the first one that people want to do? It's another case where we have a circle, right angle, because the x and y axes are at right angles, and we're asked all sorts of things. Although one of the things we're asked about is the area of triangle OPQ, and I think at that point you're definitely going to think about right angles, aren't you? You're going to think things like the area of angle OPQ is p times q divided by 2. So further down in this question there's all this area of triangle OPQ, which looks scary, but once you realise it's just p times q divided by 2, like, okay, that's not too bad at all. So this question, we'll talk about it very quickly, I suppose. If you have specific questions, do put them in chat now, because I want to move on to the other one as well, I think. Yes, okay, specific questions are coming in, but let's just say that the key for this one, I think, is realising, once again, like the warm-up question that we did before, revision question we did before, we've got a circle, we've got a triangle, we've got a right angle, there's a diameter hiding in here. The line PQ is the diameter, which means the centre is in the middle of the diameter, is P over 2, Q over 2, halfway across the triangle and halfway up the triangle. That's not how people talk. I gave it a go, but that's not how people talk. The average of the coordinates of P and Q. Nah, it's not much better. Fine. Vector displacement from Q to P divided by 2 plus the vector from 0 to Q. Maybe that's a bit better. Once you've realised that, you have an equation for the circle. We saw in a short question just now that you can use an equation like that to to talk about the centre and the radius, which is what the question asks you to do. Well, it asks for the area, but there you go. The area turns out to be p squared plus q squared divided by 4, all multiplied by pi. This question is really about p squared plus q squared and about pq. Those things are related. Okay, question in chat says, things like part I, where it asks to show that something is the solution to a problem, is verifying the given answer works enough. Yes, I think so. If the question is, show that x equals 3 is a root of this polynomial, you're not expected to find all roots of the polynomial or use some bounding principle on roots of polynomials or some hardcore maths or something, I don't know. If it says show that x equals 3 is a root of this polynomial, you can just plug in 3 and check. You're not supposed to find it pretending you don't know what number you're looking for. It's the thing I've seen people do sometimes where they think that to prove a statement properly you must approach it blindfold or something, which isn't really how, well, everything takes much longer if you approach statements wearing a blindfold. But in order to show that this is the equation, you're allowed to check that this equation is the right answer. Sometimes it's just fine and it doesn't mean anything. It's just, you can just you've had to find it from nowhere and then check that it matches. But sometimes that doesn't make any sense at all. I think that polynomial example was okay, but have we got a better one? Yeah, maybe not. Right, okay. So there's some trigonometry in part 3. I think there's some trigonometry in part 3. Not certain. How many geometry questions would there be on the paper, and can I get away with skipping all of them due to my disdain for the topic? When I was a teenager, someone said something very important to me, which is they said that my dislike of geometry was not okay and that I had to overcome it. It was not acceptable for me to be disdainful for geometry. And the point they were trying to make is that I wasn't allowed to ignore the geometry questions. And if I were a stricter teacher, I would say to you the same thing that they said to me, right? I'd say you're not allowed to skip the geometry questions. It's just good for you. And I cannot tell you how many geometry questions there will be. Cool, right. Let's get something to write on. So there's a request later on, after we found that area, oh my goodness, area of the circle is p squared plus q squared over 4 all multiplied by pi, and the area of the triangle is pq over 2. After we found that out, there's some sort of stuff down here to say what's going on. What if, so we're asked, what if p squared plus q squared over 4 times pi divided by pq over 2, what if that were equal to twice pi? Crikey. In that case, cancelling factors down a bit, I think, we would have p squared plus q squared over pq, or maybe I want plus, is equal to 4pq. So this gives me a relationship between p and q. What do I want really in life? Well, I want the angles OPQ, so maybe I should draw a little picture. OPQ. If I want this angle, then I'm interested in, well, looks like I've got p and q for these sides, lowercase p and lowercase q for these sides. So it looks a lot like a tan situation, doesn't it? Where I want tan of this angle. It's q over p. That's a quadratic equation after you divide by p squared. There's a kind of quadratic going on, right? I want this q over p. I've got the q squared. Okay, q squared is not q over p squared, but I can make it q over p squared if I divide by p squared. So there's a bit going on here to say I can get q over p out of this. And I'm not really thinking about angles at all, so much as the algebra of what am I given? What do I really want? I want this algebraic expression q over p, and I have this equation. So can I get q over p anywhere? I suppose if I divide by p squared, then I get the thing that I want, but squared. I get 4q over p. Yeah, this question did use the AMGM inequality, but you don't need to know what that is, because the AMGM inequality with 2 variables is just a fact about quadratic equations. Okay, so I think assessing success on this part is something like, if you didn't write down this, then something must have gone wrong in a previous part. You must have written down this. And then this is a mess, so probably you simplified it to this by cancelling the pi's. P squared plus q squared equals 4pq. At which point there's loads of things you might have done, I suppose. You might have subtracted 4pq, subtract 2pq to try and get a square. You might I don't know, add 3 to each side. There's loads of things you can do with the equation. But so maybe this is the step where people got stuck. Quite a few people are asking for part 3. So I guess the way I've managed to make my progress is to stop and think about what I actually want. I want those angles. I haven't thought about p over q yet. So maybe I need to divide by q squared instead to talk about p over q, or maybe I could use the fact that these angles will add up to 90 degrees. Anyway, so I'll solve this quadratic. Check's notes. The solutions to this quadratic are 2 plus or minus root 3. So I have tan theta for the angle OPQ. That's easier to write. And that is what after solving the quadratic 2 plus or minus root 3. So the angle's not very nice then. I suppose the thing that they wanted perhaps is for us to say that the angle is inverse tan of 2 plus root 3, or inverse tan of 2 minus root 3. I think that's what they wanted back in 2008 for us to write down. You're not expected to know what these things are. Have an extension activity to work out what these are, if you like. Is that on the screen? Can I get that on the screen? Down here somewhere? Yeah, an expression for 2 tan 2 theta and all the maths of this. Definitely work out what's going on there. Kay wants to know, how is the area of a circle p squared plus q squared over 4? Because I know the centre, I know the area. Part 1 was to find the area. Find the area of C. And that's the circle C, which is the circle C, which is in the top. P squared plus q squared over 4 times pi. Cool. Right. Okay. That was that one. I've got a couple of minutes left. I want to quickly look at this second question and convince you that it's not too bad. I know lots of people voted for it. So just PDF view for the last 5 minutes here to convince people that this question is not too bad. Let's see if I can do that. So once again, in this first part, we've had this thing about tan theta and the height of the triangle H, where I think the important part to start off with is that although they've drawn 2 pictures, and although there's loads of things going on out at x equals 3, actually that first part, express tan theta in terms of H, just wants us to think about a little triangle where we have theta down in the bottom corner, and the important thing is that 1, 2h lies on that line, or part of the triangle, I suppose, one of the sides of the triangle there. It goes up to 1, 2h. That's enough information for you to work out the gradient. There is loads of other information in the question about a whole circle, about another corner of the triangle, but just focusing on the centre and that corner up there, 1, 2h, that's enough for you to do tan theta and h. Where did the roots come from was a question I've just been asked where the roots come from, and I did not show you how to solve a quadratic equation. You'll need to do that one yourself, I'm afraid. I rearranged it and then used the quadratic formula. It was not interesting, sorry. I didn't want to put it on the screen. I also did it on a different bit of paper and didn't write it up on the screen. So part 2 wants us to talk about whether that point is inside the circle or not. So this is building up because, maybe behind the scenes a little bit, often these questions, when you see them, these past questions with a really complicated diagram, it's because the question is going to do several things, one at a time, and there's only space for a single diagram, so the diagram is trying to do everything. We don't need all of this at the start. The start of the question just has tan theta and h. So, you maybe draw your own diagram just with tan theta and h in it, in some sense. And then your second diagram for part 2 might have something about the circle, because that's now involved. Still haven't got anything in part 2 about the triangle, right? Nothing about the triangle in part 2. So here I might think about distance again, like we did for that short question, to think about the distance between the point 1, 2h and the origin, because I know the radius of the circle, and I know that's x squared plus y squared equals 4 again, and I know about the radius of the circle, and I know about the distance up to 1 plus 2h. So that's an inequality, some relationship, and the triangle is not relevant yet, but it's there in the pictures anyway, because there isn't space for 5 different pictures. I mean, you probably wouldn't like it if there were 5 different pictures anyway, really. Maybe we would, not sure. So part 3 is to find a line between 2 points. That's easy. And hard question, I suppose. Show that this line is tangential to the circle when, but we're given a particular value of h. So you can read that sentence, show that this line is tangential to the circle C when h is value. You can read that as saying, when h is this value, check that this thing happens. You're not being asked to show that this happens only when h is 2 over root 5. That's a totally different question. If you're asked to show that something only when h is 3 is very different from being asked to show that something is true when h is 3. Like that polynomial again. If you're asked to check that the polynomial is 0 when x is 3, that's very different from being asked to show that the polynomial is only 0 when x is 3. It's 0 or that it's 0 only when x is 3, depending on where you want to stress the word. Right, okay. I think we're wrapping up. But if you do this thing step by step and focus very carefully on the thing you're being asked to do at each step, then I think it's not too bad. So when is a line at right angles? When is a line tangent to a circle? Giving it away. When it's at right angles to the radius. So if you can find that point, maybe you can find that point by thinking about angles. Maybe you can find that point by thinking about intersections between the line and the circle. But break down just the bits you need. Chat. What does chat say? Someone says thanks, Callie. So thank you, Callie. You've done great. I will run chat for a minute here just to wrap things up if you need to go. On the maths, do you get more information than you need to try and confuse you? No, not normally. Not really that sort of test normally. That's not a promise that you will personally use all of the information available to you at all times. They're not normally supposed to be trick questions. Chill maths. Right, bye everyone. Okay. Yeah, so Jonah, you want to do this substitution thing, that's allowed. I tried to mention that by thinking about intersections between the line and the circle. That is allowed. So if we did this question, we will probably try and do it step by step and just focus on which bits we need for each part. I noticed that the value of h changes between the parts, and that's almost good news. It means that probably they're not that connected. Like in part 5, I can see it's 6 over 7. Show that this point lies on both the line and the circle. Oh, amazing. It's one of these intersection points, like in the second diagram. And then I know that, so now I know loads of things. The final part, talking about the area, is super difficult, but only because you have to break it down into lots of parts. It's more fiddly than intellectually challenging, I think, maybe. I'm not sure, I suppose. You know where everything is at this point. You have this intersection point, so you have a bit of a circle. Alpha is to do with part of the circle. In general, these expressions where you have like a bit with pi in it and a bit without pi in it, it's probably a bit of a circle and a bit of some other shape, like a triangle or a square or something. I'm sure that's not 100% true, but for a lot of these statements we've seen today, they have some pi part and some non-pi part, and pi part is something to do with circles and the non-pi part is something to do with not a circle. I'm sure someone out there can create a question where they're the other way around, and I look forward to seeing it. But when I see that on the page, I'm thinking, okay, 27 over 35, weird number. I see there's a hint at the bottom. Alpha times pi over 90, that feels like part of a circle. Alpha of 90. Right, good. Okay, I think I'm going to wrap up there. If you have other questions, sorry to cut this, well, I'm saying slightly short because we didn't do both long questions in any detail at all. But there are solutions on the Mat Live page if you want them. I hope I've said at least one helpful thing while we were looking at those. And I hope that if you're having a 1-star day at the start, that you're now having a day that is at least 2 stars. But I'm not going to do the vote again. Right, okay. We're going to wrap up. And I've forgotten how to do that. No, I can do it. We're going to be back next Thursday at 5 PM for trigonometry. Until then, we'll be back in 166 hours. But until then, have a nice evening, have a nice weekend, have a nice week. I'll see you on Thursday for another episode of the Oxford MAT Livestream. Bye, everyone. Oh. I think that didn't do the animation. We're going to do it again with the animation. Yeah, animation looks broken. Oh, that's a shame. See you next week.